Hey students, now this week we're gonna talk about blockchain, the technology. This is a 3 weeks. This is the first week. We're gonna talk about 3 weeks. We're gonna talk about blockchain, the technology. From this 3 weeks, this is the first week. We're gonna introduce what is that blockchain, and then in week 2 we're gonna talk about blockchain sectors. What are the sectors there? And the third week, it's gonna be a lot of simulation, how blockchain support crypto or how crypto use the blockchain technology. We're gonna start with the first week about the blockchain technology. Now, this class is about understanding the blockchain, not about coding a blockchain. Coding blockchain, that requires to take a degree in engineering, and then you can focus there in coding blockchain. Here's the outline. What is that blockchain? Types of blockchain terminology. This is a critical for you. You need to know, if you want to work in this field, you need to know the key terminology there. Crypto ledger, crypto mining, why the crypto miner come in, blockchain transaction, digital wallet, and consensus mechanism. What is a blockchain? Blockchain is a protocol that is tracking, settling, and enforcing transaction and contracts. And that's a critical here. Blockchain includes a network of peer nodes that must come to a consensus in the data. Here's an example of how it works. Blockchain participant creates a transaction. For example, I have a dinner at a restaurant, and we have a blockchain together. I want to send them a coin. Suppose we use Ethereum. I want to send an Ether. So I create a transaction. The transaction is broadcasted to a peer-to-peer, P2P. That means peer-to-peer network of nodes. The transaction validated by a miner or verifier. Some people call it forger, depends on the coin. The recent transactions are put into data block and added to the ledger, and then verifier is rewarding with the transaction fees. Like suppose if I was the miner or the person doing the verification, I'll be rewarded either fees, depends on the technology of the coin, or by having coins. Now in Bitcoin it's different. You go through a lottery to get a coin. That doesn't guarantee you. How a blockchain impact in technology and cybersecurity. The blockchain technology aids the presentation of a new method for DeFi. DeFi is decentralized finance, abbreviation DeFi of decentralized finance. The blockchain technology an alternative approach for the way we supply money, which is a self-governed money supply. How blockchain impact our society, policy and society. Here we explain that empower democracy, because the decision how to transfer, to make transactions through the owner of the blockchain. And if you have a lot of coins in that blockchain, then you will have more power to decide. As of now, the government decide for us about the how to supply money, censorship, resistance, immutable public data, a lot of things that impact our policy, society, and privacy. What type of blockchain? Well, there are two types of blockchain. One we call it the permissioned, and one is permissionless or non-permissioned. The key difference is as follows. With the permissioned blockchain, the set of participants are known. Like if we are permissioned, we know each other who are the participant. There is no need for a built-in currency and any sort of mining. On the other hand, with the permissionless system, participants are unknown, and there is a need for currency where their security is based on the incentive with the crypto economics. So there is a permission and permissionless. And the key is with the currency. A blockchain terminology. This is a great important things to know. What is that hash function, a cryptographic hash function, and a cryptographic hash function provides additional security capabilities by adding difficulties and detecting the contact of information or a message between recipients and senders. A cryptocurrency ledger, it's a recorded keeping and storage system that maintains participant identity, outstanding cryptocurrency balances. So for example, cryptocurrency ledger, if I have 5 coins, I send you 1 coin, you have 3 coins, then I'm going from 5 to 4, you're going from 3, in this case also 4. So the cryptocurrency ledger report that this the recipient, this is the sender, and the balance for each cryptocurrency. A blockchain is a form of a currency ledger that is a combination of series or a chain of blocks. So every few transactions become to be a block, and that will be going from one block to the other block. The crypto mining. You hear a lot about crypto mining. Now, if you do a transaction with the Visa card, what happened? You slide the card and you wait a few minutes or a few seconds, and then say wait, and you see circle and then processing and then approve, ask you to remove the card. When you do this transaction, basically immediately Visa charge, if you do it with King Super, charge King Super 2%, 2.5% fees for the transaction. If you do it in a restaurant, they charge a restaurant. Crypto mining says no. Peer-to-peer, if King Super is in my blockchain, I will send them an Ether to King Super. Suppose I bought goods with 1 Ether, then I'll send them 1 Ether to King Super. And between me and King Super, somebody has to verify the transaction. The person who verified the transaction called the miner. And this is the process of doing that. It's called crypto mining, the process. So this is done by a miner verifying the transaction, and then once the transaction completed, the miner will be rewarded for the service of doing this transaction. So there are issues with mining. So one of the issue is the person with the most hashing power has the highest probability of being rewarded. So what does that mean? For every transaction, suppose you are a miner and you want to verify transaction, but the chance to be selected to do the transaction verification, it's very limited. You have to have a lot of hashing power to be a miner. To get that, so what they do now, a lot of people make a company together, say, let's do a mining company, and you go to the blockchain, and then your chances to mine, because you're big now, is increasing. And then when you get the coins, reward for your verification, you split that across the group. But the good news is, like, if you did 1 transaction and you get 1 Bitcoin, now Bitcoin in these days are 20,000. But at some point was 64,000. So if you get 2 coins a year, that's $120,000. A lot of money. So in Visa get the money. So they do the verification and they do the money, get the money. So now we're gonna go to terminology, nodes. In each blockchain or network, there are nodes, and these nodes are varied. There's a full node, there is a pruning node, and there's a lightweight node. Blockchain transaction, another blockchain concept is transaction. Every few minutes, there is a specific number of transactions. These transactions are compiled into a block of the data represented by hash. The block adds it to the blockchain. So that's blockchain word comes from block, and another block, and another block become to be a chain of a block, act as a ledger. Here is example. The ledger is the biggest, the block hash is the middle, and then the smallest one is a transaction. So you do transaction a lot of transaction going into block and a hash, and a lot of hash and a block going to a ledger. And here's a summary of how it works. Now we're going to talk about asymmetric, cryptographic, and digital signature. We're still talking about the terminology in a blockchain. Like if you want to learn, even if you want to go to the engineering, the first thing you need to know what I'm doing now, which is outline what is that blockchain, how it works, what are the key ingredients. For example, if you want to cook a dinner, you need to know what's a tomato, what's a cucumber, what's a lettuce, rice, meat. And then they teach you how to be a good chef. If you put this together, hot water, cold, the grill has to be very hot, not very hot. But first, you need to understand the key ingredient. And now I'm doing the ingredient. So the digital signature algorithm, which is follow the following process. First, generate a key pair, private key, ASCII, and public key, P key. And then signature produces digital signature, SIG, using the M and the ASCII. Verification, putting all this together. Now, I'm talking about definition, but when we go to week 3, you're going to watch a video with illustration of these concepts. Here is a blockchain by stage. Private key going to public key, create an aplastic curve multiplication, public key hash, create this number with Bitcoin address, and then what you got something here called the SHA-256 plus this. So basically, you need 2 keys together, the hash together, and give you a number called SHA-256, a serial number, and then the person who mines will determine. The people who mine will be searching for this SHA-256 a number. Once they figure this out, then they become to be then the transaction will be verified. From these 2 keys, you get the public key with the hash, and then you get the Bitcoin address, and that will be a full transaction. And then we define digital fingerprints, the digital fingerprints for data, which is an input X of any given size to an output fixed size. This hash is deterministic. Digital wallet. The common things in our life is a regular wallet, where you put all your cards and money, and if you have other things, you put them in the wallet. What is that digital wallet? Digital wallet is a financial account that allows users to store funds, make transactions, and track payments. I have a digital wallet with Coinbase, but you can have other companies can give you digital wallet. These pieces of, so Robinhood doesn't give you, by the way, digital wallet. Robinhood, if you buy crypto with Robinhood, basically Robinhood is centralized. They have a digital wallet for Robinhood in Coinbase and others. And when you buy a transaction, they get a spread between you and the blockchain. So this is off of the counter, out of the blockchain, if you buy with Robinhood. And the digital wallet supported by near-field communication technology. Digital wallet do not require a bank account with a physical firm or a branch. As of late 21, Google combined its 2 essential payment stream, Android Pay and Google Wallet, into a single service called Google Pay. So that's example of digital wallet. Now we're going to talk about consensus mechanism, and this is critical. And we're almost done. We go through the consensus mechanism, and that will be the end. So we have a transaction. Somebody sent funds from X going to Y. X send them 1 Ether, for example, to Y. Y accept that. To complete the transaction, you need somebody to verify that the X sent, Y received. To do that, we call this, the person who verify the transaction, we call that consensus mechanism. That we agree, the X agree, when the Y agree, so that's a consensus. But how they agree, how that happened, this is a process that we're going to talk about it. Consensus mechanisms are involved in mining in Bitcoin, which verify the transaction. The consistent mechanism for Bitcoin is named proof of work. So there are 15, there are more than 15, but these are the top 15 types of consensus mechanism. So when I say consensus mechanism, that means a way of doing transaction verification. So there are 15 different ways how to verify a transaction. The first and the most common and the old technology also, I would say, proof of work. The most common one is a proof of work, which is employed with Bitcoin. Bitcoin support that using proof of work. I'll explain it. Ethereum stuck with the proof of work, but now they changed to a proof of stake. I'll explain proof of stake. A proof of work is based on advanced form of mathematical called cryptography. And that means the idea of cryptography is where cryptocurrency acquires its name. So when we talked about the keys here, we talked about SHA-256. So when you have a transaction, somebody sent funds from one side to the others, the private key with the public key, they hash together, give you a 256 through this software called SHA-256 or codes. So you get a 256 number. To verify the transaction with a proof of work, you need to have a computer guess a number. When they get that 256 number, then that means you got it right, then you verify the transaction. So you have a lot of iteration for the miner or the person who or the system who will verify the transaction, a lot of iteration till they get the number. We call this process as a proof of work. And as I said here, you get a lot of transaction number, and with this software, generate a number for each transaction, and you as a miner, you try to find this number, and then we add it to the block. Now we're gonna go proof of stake. A proof of stake says it's too much to generate energy and waste and pollution to find the number that's created by SHA-256. What we're gonna do is proof of stake. If you have a lot of stake in the blockchain, like Ethereum is a blockchain called Ethereum, and it's independent from Bitcoin. Bitcoin has a different blockchain called Bitcoin. So Ethereum says, and proof of stake case, POS, if you have a 30% of the Ethereum in the system, then you have a 30% chance to be asked to verify transaction. So if X and Y has a transaction, then the system, the blockchain, Ether blockchain, will send it to somebody to say, go verify this transaction. And then you verify it and you get fees for that, or you get, if Ethereum, if the blockchain gives you coins, then you get coins. If the blockchain gives you fees, then you get fees for that. We call that proof of stake. That means you have to have a stake in order to verify transaction. The first blockchain project, here I mentioned Bitcoin, is Ethereum. Ethereum is the second largest, and Ethereum originally started with a proof of work, but they changed the proof of stake. How to become a forger? So in Ether, if you do the mining or the verification, we call it forger. So how to become a forger? Here's explanation, 3 steps. How to be a forger and who's selected to do the transaction. Here is an example. If you have 100 coin of blockchain system that is 1,000 coins, the whole blockchain is 1,000 coins, and you own 100 of these coins, then you will have a chance of 10% to be the verifier. When you do that, you can get fees. So that can be a good business to be in Ethereum. And I know a lot of people who are in the Ether blockchain, and their job is only to verify transaction and get fees for that. Difference between POW, proof of work, and proof of stakes. PO is a much more power demanding, and POS is more scalable, the proof of work. And then there's also a proof of authority. That's another system. The key difference in proof of authority versus other consensus mechanism is proof of stake and a proof of work is there is no competition edge that can be created as you being able to validate transaction in that's solely reliant on your authority. And the benefit, one benefit of the proof is that requires nearly no computing power, which makes this proof very eco-friendly. So that's my favorite one. proof of authority, which is the POA assigned the authority of being able to validate transaction to a small selected group of individual. So there will be a group of individual, you go verify the transaction, and it costs almost nothing. No, it costs something because they'll be rewarded. But in terms of energy consuming is less. And here explain the difference between POW and POA, POS and POA. And then the appendix, here is example real time. If you click here, you can get the link for real time monitoring. You can open that and you can see real time monitoring the blockchain. So you can click on the link and here's what you see there. Here are the codes, blockchain codes. If you want to be a blockchain coder, you want to work in this business, then you have to go to college, engineering, and take the classes. And here's some codes, how to do it. Now, I personally don't know how to code, but I know how to change it. So I know I can change. If I want to add a token, I know how to do that by myself. So all what you need to know is how to make a difference, a change here. So you can learn without knowing the entire software. How to become a miner, here explain how to become a miner. You have to buy a GPU. And if you live in a country or a state or a city, utilities is cheap, then great. You can be a miner and you can do that part-time job because the system does it for you. You didn't have to be focusing 24/7 on the phone or doing something. The system doing that for you. You just buy the system, you run it, and we'll get you set. And here is also application, how to get how to be a miner. This chapter, here are the questions. What is the blockchain? How it impacts society? What's a node, hash, digital wallet? All explained in the slides. Again, I want answer to be short and sweet. The answer can be 1 line, 2 lines. The whole homework, that homework would be a page, page and a half maximum. Short and sweet will do it for me. Thank you so much. I think that's all I have for you today. Thank you so much, and I look forward to our next class.